Salvation International Preparatory School. Salvation International Preparatory School. A place to be, a school to go. We'll build you up from the cradle to university. Salvation International Preparatory School. Salvation International Preparatory School. A place to be, a school to go. We'll build you up from the cradle to university.
Good day, everyone.
Good day, senior.
My name is Favor Oka, and I'm an SS3 student of Salvation International Preparatory Schools. This is SS3 week, and I'm going to be taking you students chemistry on the topic rates of reaction. Firstly, rate of reaction is the number of moles of the reactants converted or product form per unit time. And we have the formulas on the board. Reaction rate is equal to the change in concentration of reactants over time taken, or mass of reactant over time taken, or volume of product over time taken. It is usually expressed in gram per minute. We have an example on the board which says when 0.5 gram of calcium triazocarbonate 4 was added to excess dilute hydrochloric acid, carbon 4 oxide was evolved. The entire reaction took 5 minutes. What was the rate of the reaction? Now to solve this, we are going to use the second formula. Why? Because the reactant evolved mass, and the second formula is the mass of reactant over the time taken. The mass of the reactant, which was 0.5 gram, over the time taken, which was 5 minutes, which will give us 0.1 gram per minute. We need 0.1 gram of calcium triazocarbonate 4. We evolve carbon 4 oxide in 1 minute. Now let's go to the rate of the reaction. Is reference to the collision theory, which assumes that there must be effective collision between the reactant particles for a chemical reaction to occur. Now, the factors affecting the rate of reaction will influence the frequency of the collision between the particles and the activation energy of the reaction. Now, the factors affecting the rate of the reaction are nature of the reactant, concentration of reactants, surface area of contact, temperature, presence of light, and presence of catalyst. Now let's begin from the first one, nature of reactant. For instance, when a piece of iron is placed in dilute hydrochloric acid, the evolution of hydrogen is going to be slow. Why? Because iron is closer to hydrogen in the electrochemical series. But when a piece of zinc is added in dilute hydrochloric acid, the evolution of gas is going to be rapid because zinc is further away from hydrogen in the reactivity series. But when a piece of gold is placed in hydrochloric acid, there is no evolution at all because gold is below hydrogen in the electrochemical series. Now this is because different elements have different energy content. Now the second one, concentration of reactants.
As a parent, I have always asked, how can I prepare my children for the infrastructural development and socio-economic evolution of the next decade? With the ongoing speed of globalization, how can I position my children to perform excellently in a rapidly changing society? The answer is and has always been to give them a solid foundation, academically, spiritually, and morally. Salvation International Preparatory Schools, with her team of highly qualified tutors, conducive environment for learning, state-of-the-art computer and science laboratories coupled with quality day and boarding facilities, is the place to be. For more information, contact 080-233-76135. SIPS remains the birthplace of leaders.
Reaction will occur more faster when they are enclosed in a small space. That is, the collision of reactants will increase the reaction. Now let's go to the third one, surface area of contact. When dilute acid is added to marble chips and powdered marble, there's a marked difference. Why? Because in the marble chips, it's going to be slower, but when it is added to powdered marble, it is going to be rapid, because the more chips, the more faster the reaction will be because there's surface area of contact. Also, when zinc dust is burnt in oxygen, it will be faster than when it is added to zinc granules. Then let's go to the fourth one, temperature. We all know that temperature will increase the rate, high temperature will increase the rate of reaction, and low temperature will reduce the rate of reaction. That is why refrigerators have low temperature to reduce the chemical reaction that spoil food. Now, the fifth one, presence of light. Some reactions are influenced by light. Let's take the reaction between hydrogen and chlorine. It is negligible in the absence of light. It is moderate in daylight, and it is explosive in bright light. These reactions are said to be photochemical. Other examples we have reaction, the composition of hydrogen peroxide, reaction between methane and chlorine, and photosynthesis in plants. Then let's go to the sixth one, which is the presence of catalyst. What is a catalyst? A catalyst is a substance that alters the rate of reaction but does not undergo any permanent change at the end of the reaction. Some positive catalysts tend to increase the rate of reaction, while some negative catalysts tend to reduce the rate of reaction. Now let's take an example of preparation of oxygen by burning potassium trioxoperate 5. With the use of a catalyst, which is, for example, manganese 4 oxide, with the use of that catalyst, the reaction will require small heat, but when the catalyst is removed, a lot of heat will be added to potassium trioxoperate 5 to yield the same similar results. Now, positive catalyst, which is manganese 4 oxide, has increased the rate of reaction of preparation of oxygen from potassium trioxoperate 5. Now we have come to the end of the class, and I will see you in our next class. Thank you.
As a parent, I have always asked, how can I prepare my children for the infrastructural development and socio-economic evolution of the next decade? With the ongoing speed of globalization, how can I position my children to perform excellently in a rapidly changing society? The answer is and has always been to give them a solid foundation, academically, spiritually, and morally. Salvation International Preparatory Schools, with her team of highly qualified tutors, conducive environment for learning, state-of-the-art computer and science laboratories coupled with quality day and boarding facilities, is the place to be. For more information, contact 080-233-76135. SIPS remains the birthplace of leaders.
Good afternoon, class.
Good afternoon, senior.
My name is Homo Olivia. Today in SIPS is the SSS 3 day. So I'll be teaching you all base science on the topic work, energy, and power. So before we start, I'll be defining these basic concepts. Work. Work is any activity that requires energy to be used on. So as work is done, energy is being used on. So it can be represented mathematically as W equals to mgh. M for mass, G for acceleration due to gravity, then H for height, length, capability. So energy is the ability or capacity to do work. Energy can be represented as mgh. It's the same as work done. Since as energy is used up, work is being done. So power is the time rate at which work is done. So power is equals to mgh over t. That is work done over time taken for the work to be done. So on this note, we'll be solving some questions on work. So a girl moves a block of mass 8 kg through a distance of 5 meters. Calculate her work done. Okay, so let's get to the solving. If you look at the question, you see that work was not given to us. That's what we're looking for. So work is unknown. They gave us the mass of the block as 8 kg. So m is equals to 8 kg. Then the distance moved by the block was 5 meters. And acceleration due to gravity is always 10 meters per second. So the formula, we'll be using formula W equals to mgh. So the mass was given as 8. So we're multiplying it with the acceleration due to gravity, that is 10 times the distance moved, that is 5. So 8 times 5 is 40. 40 times 10 is 400. But you know, we cannot leave it as this. The SI unit for work is joules, so leave it as 400 joules. This is the correct answer. So, energy. We talk about energy is the ability or capacity to do work. Energy of different forms. We have different forms of energy. We have the mechanical energy, the kinetic. We have the mechanical energy, we have the electrical energy, we have the sound energy, nuclear energy. But in this level, we're concentrating more on mechanical energy. Mechanical energy of two forms. We have the potential energy and the kinetic energy. The potential energy is the energy stored on the body at rest. It's represented mathematically as potential energy is equals to mgh, same as work for the one for energy. Then kinetic energy. Kinetic energy is the energy exerted on the body at motion. Kinetic energy is Ke equals to 1/2 mv square. M for the mass, V for velocity. So we're taking the question of potential energy. A ball on a roof has a mass of 200 grams and the roof is 8 meters high. Calculate the potential energy before it falls. So if they give you a question like this, they will find the potential energy. So we use the formula equals to mgh. Here they give us the mass of the ball as 200 grams. If they give you a question the energy in gram, you convert it to kilogram first before solving. So to kilogram, to convert to kilogram, you divide it by 1000. So that would be equals to 0.2 kilograms. This is the mass we're making use of. Then they give us the height of the roof as 8 meters. Then acceleration due to gravity constant. That is acceleration due to gravity, that is constant. That is 10 meters per second. So imply all these values we have gotten into the formula mgh. So the mass, which is 0.2 times 8 times 10. 8 times 0.2, that is 1.6 times 10, that would be 16. That's what be 16 joules.
Salvation International Preparatory School. Salvation International Preparatory School. A place